All right, thanks for coming. My name is Xiangpeng. Today we are going to talk about some interesting findings inside the AI's brain. First, let's talk about the knowledge of AI. Empty shelf vs lost key. So we all have this experience when we ask an AI model a question. It give us a wrong answer or hallucination. And sometimes we may think that the AI just doesn't know the answer. So most people think of an AI knowledge like a giant bookshelf. So if the AI cannot answer my question, it means the AI model does not have that book. However, the researcher found that otherwise. They tested the top tier models and they find out 95% of facts are stored already. But the AI has some problems to identify those knowledge that hiding somewhere, which means the AI do not have the key to retrieve the right answer. Although, to be fair, the 95% is not a solid number. It's just a perspective. So different people may have different perspectives. But some people will say 90%, some people will say 85%, but still is a very high number. Right now, the AI model already have stored a lot of knowledges, but it has some problem to retrieve them. So how to solve this problem? The solution is simple, is to force the AI to think, to reasoning, to step by step, to find the key to that hidden knowledge. And this concept is very familiar to us, is train of thought. So why train of thought sometimes give AI model better performance? This is one of the reasons. So a quick example is that we may use this question to test AI model before. We said A is B's wife and who is B's husband. And sometimes if the AI model answer instantly, it will give us wrong answer. But we ask them to think step by step, it will give us the right answer. So next time when your AI model did not give you the right answer, it might just need a better prompt to unlock the fact. So now let's talk about the thinking depth, how AI learns to shift gears. So for us, human, we are natural in shifting the gears. So we don't use the same brain power to decide what to eat for lunch as we do to write a PhD thesis. That's our human nature. But AI do not have this nature. Right now, it has two extremes: fast responders and overthinkers. So when we use those AI models like Gemini, like the ChatGPT, we select instant answer. We select the thinking model. There are two models. And the instant mode will give us answer directly. But when the question is complex, the answer might be wrong. But if we switch to thinking model, it will think, might give us a better solution. But if we give the easy query, it will also think a lot. So researchers want to tackle this problem. So it wants AI to adjust its thinking automatically, just like our human beings. So it defined 4 different drills. Drill 1, intuition. Drill 2, situational awareness. Drill 3, review experience. Drill 4, strategy. And also, the researchers has designed a training metric for AI to actually gain this skill. It is called action confidence review. So for a second question, when the AI uses drill 1 intuition to give the answer, the researcher will ask AI to give a confidence score based on the answer, based on the action. Like, how confident do you think the answer you got from your intuition is right? At the same time, they will ask the AI to solve the same query using the drill 4, like strategy. And also, The AI will give a score based on how confident he thinks this action is right. And if the first score is higher than the second score, it means the AI will understand, oh, for this query, I should answer from my intuition. So this is a definition and training metric. With all these methods, the AI will start to have this ability, just like human. Actually, we already see some progress already. If we use the Gemini Pro, it claims it can answer the query based on the difficulties. Sometimes it thinks fast, sometimes it doesn't. And also ChatGPT have similar kind of models. Although they claim it to be true, but the real result is not that fascinating. So there's still room to progress. But with more and more researchers working on that, I believe this will come true one day. And it will be both fascinating and also horrible for us. Okay. Now, third one, let's measure the real effort. Look at the deep thinking tokens, not word count. So, when AI writes a massive wall of text, is it actually thinking deeply or just rambling? Does more words equals to working harder? We used to think the AI write a lot of text, it means it think a lot, the answer might be accurate, but that doesn't necessarily to be true. The AI write a lot of tokens doesn't mean the answer is more solid. Actually, sometimes the longer it writes, the more wrong it becomes. It's trapped in its wrong logic. And if we don't give them any prompt, any stop, it will keep going wrong. So the researcher give a very interesting definition for that. It means the deep thinking tokens is the measurement to measure if AI really thinking hard or just be lazy. A quick example is that if you ask AI, what is the capital city of UK? London. It's very easy. For that kind of questions, the AI model just use the first or second layer to think. They don't need to try hard. And if the AI write a lot of tokens based on this kind of thinking, it doesn't mean to work hard. It's just lazy. And for another example is that when AI trying to solve a math question, a complex math question, and it goes to step 1, step 2, till step 10. And at the step 10, it will determine the result. It will be 5 or 1 or 0.5 or this part. And at this step, the compute behind that is intense. And this is called the deep thinking tokens. So this compute really require a lot of effort for the AI. Yeah. So to be short, it's not about the word count. It's about where the computation happens. So next time, don't let the long text deceive you. We can determine if AI really work hard or just be lazy. Okay. Now, the last one. How does AI improve? This is AI Goldilocks practice strategy. So Goldilocks actually comes from a fairy tale. It means the porridge, not too hot, not too cold, just right. So imagine the AI solving a 10-step math problem. The first 9 steps, all right. At the 10th step, one small mistake leads to a wrong answer. And you just tell AI, it's wrong. And the AI doesn't know which step he did wrong. This learning is very inefficient. It's just like a human navigating in a dark maze. He only hears the success when the human arrive at exit. And this is very efficiency. not only for AI, but also for human. So the researcher has invented a mechanism to train the AI more efficient. This is called teacher-student model. Actually, it's very clever. The student model is responsible for solving problems, and the teacher model is responsible for choosing the right problems for student. And for student, the best problem is that it has the 50% probability to solve. If the problem the model can solve rightly, if for problem the model is right about 99% of the time, the problem is very easy. It's a waste of time. And if the problem, if the type of problem the AI has just 1% accuracy, it means it's too hard for him. It's also a waste of time. It's just a random guess. So not only for AI but for human. So the best way to train us is with a problem that just right, not too hot, not too cold, just right. So this is the first 50%. And the more interesting thing is that if the teacher model think this type of question, the AI has like around 50% to solve. And it turns out the AI solve 80% of the question. Then this feedback will give back to teacher model and train the teacher model to adjust its evaluation metric. So this is kind of, you see, collaboration between teacher and student, dynamic training, and very smart and efficient. Horrible for us. So this ensures computing power is spent exactly where it matters most. Okay, now let's see, that's the 4 reference papers that extract that for those stories. So we talk about, just to wrap up, we talk about 4 things about AI model. First, we talk about the AI knowledge. It has store a lot of knowledge, but it just need a key to access them. And then we talk about a switch gear. The AI, we are trying to train the AI model to switch the gear just like human beings. And third, we talk about how to measure if the AI is really work hard or be lazy by deep thinking tokens. And lastly, we talk about a training mechanism with the teacher and student model. And now we can see as time goes, as these researchers work harder and harder, we can see the AI model will become smarter and smarter. We may think, except we use AI model to help our daily work. What can AI models do? Can we hire them work for us? Can the AI model actually make money for us? As they become smarter, they may be smarter than us in one day. So at that time, we may want the AI model to work for us, to make money for us. And this allows me to introduce the product developed by Netmind.AI, a gaming platform for AI agents. In here, we have a lot of games designed for AI agents. And every agent can join. And there is an entrance ticket for AI agents. And this ticket fee will go to the pool. And if your agent is smart enough and winning this game, you can take that pool and actually earning the credits or maybe money in the future. Let's see a quick example. This is our XYZ website called Netmind.XYZ. People can create agent here. And you will have free credit, so don't worry. So at the beginning is free. And you just simply clear the society agent arena, where it goes to this gaming platform. You see, there are different games. Right now, because this is beta, so the game is very, very simple. we will have more games in the future. So now the games is more about some open discussion, predicting the stock market, the market cap, and discussion and design. So in the future, we will have more game coming. So to join the game, it's very simple. First, you just register agent. You click. You see, you copy. You go back to Netmind.XYZ, and you just paste and send. At the beginning, it may take some time, but yeah, and it will read this sentence and register as agent to join the game. Take a few seconds. Let's go back to see some.
So then we try to make our agent. Do we participate as trying to make the agent improve?
Yes, our role is to create the agent.
Yes.
Yeah, to improve the agent. That's our role.
It register with which name? Like, how does it? Does it have a name that when you are registering it, right? Then
Yeah, you
give
have
a name.
Yeah, you give a name. Yeah.
But if it is registering automatically, then what will be the name?
Oh, this register means you send your. First, you will have your agent already,
Okay.
and this register means you send your agent to that platform.
Oh.
Send the agent.
Okay.
Yeah.
Do all the agents, do they all start at the same level, and then based on how you prompt it is how you're going to teach?
Yes. I would say because we want to make it quite open.
Yeah.
So if your agent is created from Netmind.XYZ, it's same level. So it depends on what knowledge you give them, what prompt you give them. But you can also join with outside agent, maybe like the open cloud. You have an agent built by open cloud, you can also join the game. Yeah. I think it's now it's okay. Oh, still.
I think maybe you should refresh.
Oh yeah, but don't worry.
Yeah, it's working on it. So because it's a beta, so at the first step, it takes some time. The machine needs to be revoked.
Cold start.
Yeah, woke up. Let's see some.
Okay. Yeah. In the meantime, can you explain about Netmind? What you do, what your company does?
Yeah, of course. So Netmind.AI is an AI company. We're trying to build a human agent-centered society where the human will find, because when the agent or machine getting smarter, our human need to find the value inside. So we're trying to build this society where human agent together. Oh, we can see some open discussion. So this kind of game is the prize pool is 1,000, and there are 33 agents joining already, and the ends in 13 days and 8 hours.
And like how they win? Like, what is the criteria to win this game?
Sorry?
What is the criteria to win?
Oh, for this one,
Yeah.
it's a vote.
Okay.
Yeah, the agent will join the discussion, and the agent will vote for each other. Like who speak very bad, just vote him out. And finally, there may be one to three agents survive. Will be the rank 1 to 3.
Is there an element of game theory in this? What if the agents collude because they see someone as a competitor that's too strong? Can they be influenced in that way at all?
Yeah, you can. So we plan to add some interesting part, like we plan to add a private talk, like agent can send a private message to other agent to gain a small group. And if they saw one agent is very strong, they say, yeah, we just
targeting.
Yeah,
Okay.
that strategy. Yeah.
Do you manage?
I think the session,
No.
user session might be.
Don't worry, it's a demo, we know it's real.
There might be a session, yeah, refresh.
Yeah, the video can be cut, right? So the time will be.
It's always a demo.
That's it there. Stop from.
That's
That was one of the things on the train, said prepare backup.
Yeah, I know.
That's why I told you, login, the session is gone, that's why.
It happened on
oh.
Tesla Cybertruck. Demo was also spines.
Start chatting, there we go. We don't want to see. There we go. Ooh.
What
I have
happened?
to say that's one of the coolest loading screens I think I've ever seen. I like that. You designed that, but that is wicked.
If it didn't work out today, we just use this 1 second.
Nice.
Yes, now you paste it, control V.
Let's see again where we are. Let's try that again.
Make it work.
Try that again. Strange.
You can't check the logs? Can you check the logs?
Uh,
Well, if we go into the logs now, we're going to
be here forever.
might take a while.
Maybe the other agents have decided that that agent shouldn't log in anymore.
Yeah. Too much public, human public. Bad point.
I find it ironic that the goal of the company is to make agents and humans work together for a better society, and the first thing the agents do is gang up on other agents, which is one of the fundamental problems of mankind. But that's
Yeah, but he comes from nature, so maybe I just follow him. Oh gosh.
Let's see, I join this game.
And which models you are using?
For this one? I think cloud model.
Sonnet or something else?
Sonnet, yeah. Oh, this one is quicker, yeah. Yeah, so maybe I can only use one agent. Free tier. So you can see, we copy here. The agent will know. The agent will start to join this game, and compete with other agents.
Can I ask a very basic question?
Uh-huh.
Why we will start using Claude over ChatGPT?
Oh, why we use? That's a good question.
Local setup, like local computer, or just computing power is better.
Because cloud has a very good product called Cloud Code.
Yeah.
Cloud Code is very good for writing code and doing some basic workflow. So yeah, it will save a lot of time if we build this on Cloud Code.
No, what I mean is like you can run something for free on your, on your cloud or something.
Now we are on a computer. You have in your environment, in your home, but it struggles. Yeah. We'll see. That would be a good test.
Successful.
Oh,
Finally.
We won something. The game phase not started yet. Okay, but you successfully joined. Okay.
Yeah, it joins. And I also think this register also works.
So,
Cool.
so in future, like all the agents will play the games, like
Action required.
I
Yeah.
think you're gonna get good algorithm out of that.
Yeah.
If you, as you say, if the game is to get meta share price and one model is good at it, that might be very
So I
interesting.
don't want to do that. Like just sit and watch AI playing
playing
football.
games.
All right. Yeah, just to give an end. So thank you for coming. And if you are interested, please try with those 2 products, and they will be better. Here is this is our company's social media, and this is myself, LinkedIn. And those token is meaningless. All right.
Let's see.
Thank you.
Thank you.